Hi, so today in this video we're going to be talking about right triangle trigonometry. We're just going to kind of be introduced to right triangle trigonometry, if I can speak. So the first part of this is actually what we did yesterday. So recognize the sides of a right triangle relative to the reference angle. And then the second part is what we're doing today. We're going to define trigonometric ratios, sine, cosine, and tangent. Okay, so first of all, what is trigonometry? Trigonometry is the study of relationships between the sides and the angles of triangles. So basically, it's how are the angles in a right triangle related to the sides. And of course, it can be expanded to other triangles, but today we're concentrating on right triangles. So we already talked yesterday about these first few slides. What is a right triangle? And then depending on which reference or perspective angle I'm looking at, so on this one, if I'm looking at angle A, this side is going to be the opposite side, this side would be the adjacent side, and then the hypotenuse is here. If my perspective angle changes to C, then my hypotenuse won't change, it's still there, but now the opposite side is AB, and the adjacent side is BC. So just a quick review of yesterday. Now what we're going to do is define sine, cosine, and tangent. So sin here is short or an abbreviation for sine, cos is an abbreviation for cosine, and tan is an abbreviation for tangent. Okay, so A here is the angle, so it's talking about this angle right here, angle A. And this is the definition of what sine is. So sine of an angle is equal to the opposite side over the hypotenuse. Make sure you write these down because you're going to need these. Cosine of angle A is equal to adjacent over hypotenuse. And tangent of angle A is equal to the opposite side over the adjacent side. So it's relating the angle to the ratio of sides. Sine being the opposite over hypotenuse, cosine being adjacent over hypotenuse, and tangent being opposite over adjacent. So in a right triangle, like a certain angle is always going to have the same ratio of sides. So if I want to find the values of the trig functions below according to this triangle, so this is the hypotenuse, it's 10, this side is 8, and this side is 6. I want to find sine of angle x. So the way I know what my reference angle is just by looking at what is right next to sine. So this is my reference angle because that's angle x. And then I'm going to give my answers in fraction form. So basically, I'm just trying to find which ratio of sides I have here. So from the previous slide, we know that sine is equal to the opposite side over the hypotenuse. So if we're looking at x here, the opposite of that side is 8. And then the hypotenuse is 10. So the sine of angle x is equal to 8 over 10. Okay. Now it's asking me cosine of x. Again, x is my reference angle. Cosine is the adjacent side over the hypotenuse. So 6 over 10. Now it tells me to leave my answer in fraction form. So I'm going to leave it as 8 over 10 and 6 over 10. Technically, I could reduce this to like 4/5, and it would still be the same ratio, right? But since I'm trying to kind of get used to seeing the sides over the sides and I want to be able to look at the triangle and see them easily, I'm just going to leave them like that. Tangent of x is the opposite side over the adjacent side. So here's x. So the opposite side's 8 and the adjacent side is 6. Okay. So let's try another one. So on this triangle, it's very similar, right? And it's still asking me to find from x. But now my side lengths have changed, 25, 14, and 7. So again, sine is opposite over hypotenuse, so 14 over 25. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, so 14 over 7. Okay. Now here we have sine x, but then we want to find cosine of z. And it also says here to give my answer in decimal form. Okay. So I'm going to look at x first. So here's angle x. So the opposite side of that is 1.2. The hypotenuse is 3.2. So sine x is 1.2 over 3.2. But because this told me to put this in decimal form, I'm going to get my calculator out, and I'm going to multiply, or not multiply, I'm going to divide 1.2 divided by 3.2, and that is equal to 0.375. So I'm going to just change that ratio into a decimal, and that's going to be the way I give my answer on this one. Okay, now cosine z, remember cosine is the adjacent side over the hypotenuse, so I look at angle z. Adjacent is 1.2, hypotenuse is 3.2. So again, 1.2 over 3.2, which is about 0.375. Tangent of x, tangent, remember, is the opposite side over the adjacent side. My reference angle is x, so opposite would be 1.2, and adjacent would be 3. So 1.2 over 3, and I'm going to grab my calculator again. That is equal to 0.4. Sine z, so again, now I'm looking at z here as my reference angle. The sine of that angle would be the opposite, which is 3, over the hypotenuse, which is 3.2. And 3 divided by 3.2 is equal to 0.9375. Okay, the cosine of angle x, so now x is my reference angle. Cosine is adjacent over hypotenuse, so it's going to be 3 over 3.2, which is also 0.9375. And then tangent of angle z, so this is my angle, is opposite over adjacent, so 3 over 1.2, which is equal to 2.5. Okay, so notice here that the sine of x and the cosine of z are the same. Also, the sine of z and the cosine of x are the same. Okay, think about why that might be for a moment. So because I'm changing reference angles here, when I'm looking at sine of z, sine is opposite over adjacent, so that would be 3 over 3.2, right? But when I change over to angle x is up here, and angle x wants the adjacent side over the hypotenuse. The adjacent side to x is the opposite side for z, right? So that's why those will be the same. So if I have angle x and angle z, any two acute angles in a right triangle, the cosine of one will always equal the sine of the other. So now, if you have a calculator, grab it. We're going to make sure your calculator is in the correct mode to evaluate the sine of 19 degrees. So when it comes to trigonometry with your calculator, there are two modes. One of them is degree mode, and one of them is radian mode. Okay. So most of the time it's automatically in degree mode, but if you look at the screen, it usually says somewhere on the screen either degree or DEG or something that lets you know that it is in degree mode. But if you don't see that, go ahead and hit the mode button, and when you hit the mode button, you should see an option for degree or radian. You want to make sure degree is highlighted, and then just clear out and go ahead and enter sine of 19. So sine looks like SIN on your calculator, so push that. It should bring up this with an open parenthesis. So you're just going to put 19 inside that parenthesis and then close it off. And you should get, if your calculator is in degree mode, you should get 0.325, and I'm going to round off there. So about 0.3256. So that is the sine of angle 19, 0.3256. If you didn't get that, it's probably in radian mode, so try to figure out how to change to degree mode. Cosine of 67 is equal to 0.3907. Oops. Oh goodness, my pen is, okay, there we go. And then tangent of 25 is equal to 0.4663. Okay. Now what is this? What does this mean? If I put sine 19 in my calculator and it gives me out 0.3256, what does that mean? So if you think about your right triangle, if I have a right triangle, and in this case of sine 19, if one of the angles in the triangle is 19 degrees, then if I were to take the ratio, sine, remember, means opposite over hypotenuse. If I take the ratio of opposite over hypotenuse, in a triangle with a 19-degree angle, it's that ratio, when I divide opposite by hypotenuse, is going to be equal to about 0.3256. 0.3256 would be the ratio between the two sides. Okay, so that's kind of what it means. So same thing for this one. If I have a right triangle, and one of the angles in here is 67 degrees, then the cosine, or the adjacent side over the hypotenuse, when I take that ratio, it should equal about 0.3907. Okay. So now we're going to look at the inverse trig function. So on your calculator, above the regular sin, tan, cos, there is a little sin minus 1, or tan minus 1, or cosine minus 1. So that does not mean sine raised to the power of -1. It actually just means that sine inverse, this is the inverse function for sine. So every mathematical operation has an inverse. So like the opposite, or the inverse of adding, is subtracting. The inverse of multiplying is dividing. The inverse of squaring is square rooting. So basically in an equation, if you want to undo something, you use the inverse. Same thing applies for sine, cosine, and tangent. The inverse of sine is sine inverse. So what that means is that this input right here, this 0.56, if I put this inside sine inverse, 0.56 is that ratio of sides. So I have a right triangle, and I know that if I take this as my reference angle, right here, that if I took the opposite side over the hypotenuse, okay, the opposite over hypotenuse, if I were to divide the opposite side by the hypotenuse, I would get 0.56. And so now if I take the sine inverse of that ratio, it's going to tell me what that angle in there is equal to. Okay, so let's go ahead and try this. So make sure, again, that your calculator is in degree mode. It should still be. It's not going to just like automatically change itself back. So go ahead and hit second sine, because that's going to bring up the little sine minus 1. Put in 0.56, and you're going to get 34.055. Well, actually 0.6 if I round it. So basically 34 degrees, right? If I were to round it. So the sine inverse of 0.56 is equal to 34 degrees. Okay. So the ratio of the opposite side over the adjacent side is 0.56 when the angle is 34 degrees. Okay. So actually go ahead and try now. What if I do the sine of 34 degrees? What does that give you? So remember, this is just regular sine, this is inverse, but if I do regular sine of 34, I should get a decimal very close to sine 0.56, right? Which I do. It gives me 0.559, so that rounds up to 0.56. So again, sine and sine inverse, they are inverses of one another. This one, sine, you take the angle and plug it in, you're going to get the ratio of sides. The inverse, you plug the ratio of sides in, and you're going to get the angle. So tan inverse, just put it in your calculator, second tan of 2.5. That should be equal to about 68 degrees if I round it off. And then second cos, or cos inverse of 0.34 is equal to 70 degrees. Again, I rounded that off. So that's about it for today. So go ahead and try the problems on the worksheet. If you have any questions at all, please don't hesitate to email me, and I can try to help you with that. Have a great day.